Okay, guys. So what I left off with yesterday, I'm going to redo this because I want you guys to see this, is the trend for ionic radius. Okay. So can you jog my memory here? In group one, what is the charge of every ion that I taught you so far in group one? +1 is correct. So is it gaining an electron or is it losing an electron? It's losing one. What is the charge of everything in group two, the alkaline earth metals? +2. What is the charge of everything in group 13, the column that starts with boron? +3. And what's the charge of everything that's in column 4 or 14 that starts with carbon? +4. Okay. And so when you're in those columns, if your charge is +1, how many electrons are you losing? Huh? Remember, proton number doesn't change. Can you get that, Evan? Just say Mr. Thorson's class. It's probably for you again, Aiden. I don't know. You said you're signing out at 11:30. 11:45. 11:30. You didn't leave. Hold on.
Oh, it's 11:45.
All right. This will be on YouTube, Aiden. Okay, so proton numbers don't change. If your proton number doesn't change and you have a +1 charge, did you gain an electron or lose an electron? This is where I think you guys are totally getting lost. If my proton number doesn't change and I say, for instance, 11 protons. If I have a +1 charge overall, how many electrons must I have? 10. I thought seeing it would make it better for you. So everything in group one, do they gain or lose 1 electron? All right. Everything in group two has a +2 charge. Knowing that proton numbers don't change, do they gain or lose electrons and how many? Lose 2. How about things in group 13 with a +3 charge? It's +3. So do they lose or gain 3 electrons? Lose 3. Here's where the disconnect is. And man, I am having flashbacks to when I was in high school, you would take chemistry junior year. You're having a little bit of trouble trying to correlate that. +3 is a loss of 3. I think that's where you're starting. Am I getting warm? A little bit. When you have a +3 charge, here's what I need your brains to see that as. When you have a +3 charge, you have 3 more protons. 3 more. So hypothetically, if I told you that you have a +3 charge, or let me write it properly, you have 3+, and you have 15 protons, how many electrons must you have in order to have that +3 charge? You must have 12 electrons, and that's phosphorus, by the way. Or not phosphorus, that's aluminum. Or I just made something up. Whatever. It's neither of them. So the trend that you should be seeing from 1 to 2 to 3 to 4, is the ionic radius getting bigger or smaller? Is it decreasing or increasing? As you're losing 1, losing 2, losing 3, losing 4. It is decreasing. But then you hit a wall. And now I want you to look at group 15. We just did this. In group 15, you got nitrogen, phosphorus, arsenic, and so on. How many electrons, or let me ask a better question. Do they gain electrons or lose electrons to be stable in group 15? They gain. How many do they gain? So what's the overall charge? -3. What's the charge of things in group 16? -2. How many electrons did they gain or lose? 2. Did they gain or lose those? They gain. And how about everything in group 17? They gain 1. So what is their charge? So if you go from gaining 3 to gaining 2 to gaining 1, what is the trend from 15 to 16 to 17? What is it? You're gaining 3, then gaining 2, then gaining 1. What is it, Connor? It's decreasing again. So what I need you guys to know when it comes to ionic radiuses is that right after 4, between group 14 and group 15, you kind of started over. So let's keep doing this. So from here to there, you're decreasing. Then you start over, and from 15 to 16 to 17, you decrease again. Yes. From 14 to 15, you increase. Just that one step. That's right, Olive. Anything with that that material, that trend that you may have questions on? Connor? It's a wall there. It kind of hits a wall and starts over because you went from losing electrons to gaining electrons. From group 1 to group 2 to group 13 and 14, you were losing 1, losing 2, losing 3, losing 4. And then you stop losing and then you start gaining. But when you go from gaining 3 to gaining 2 to gaining 1, it's getting, look at me, guys. I can do a visual for you. I gained 13. I've only backtrack, rerun. I've gained 3. Now I've gained 2. Now I've gained 1. What happened to the radius? It got smaller. Can you get that, Nella? Yeah. All right, let's move on to the next trend. And that is going to be ionization energy. All right. See if you guys can tell me a couple things. First off, what is a cation? Varun? It is a positively charged ion. Okay. For a cation to form, must an atom gain an electron or more, or lose an electron or more? It must lose. Okay. So here's the trick. The negative electrons are attracted to the positive nucleus. They're attracted. That is called an electrostatic attraction. Positive to negative is known as the electrostatic attraction. Negative to negative, positive to positive, it's called electrostatic repulsion. In order to get that electron pulled away, you must be stronger than the force that's keeping it there. I'm going to say that 2 more times. In order to remove the electron from that atom, you must have a force stronger than the attractive force that's holding the electron there. One more time. In order to get the electron pulled away from the atom, you must overcome the attractive force that is keeping it there in the first place. That nucleus does not want to lose this electron. It is attracted to it. You've got to be stronger. You've got to be stronger and pull it away. So the negative electrons are attracted to the positive nucleus. To remove one or more electrons from an atom, the attractive forces between the nucleus, which is positive, and the electrons, which are negative, must be overcome. If Ben and I are walking down the street and he has some killer addiction for Steak and Shake, I've got to be able to be strong enough to pull him away from that restaurant because he's attracted to it. My ability to pull him away has to be stronger than his draw towards it. You got to be able to overcome an attractive force. This force is called the ionization energy. The ionization energy overcomes the attractive force between the electron and the nucleus, so you're able to pull the electron away. Again, the ionization energy is the energy that you can use, that is used to overcome the attraction between the nucleus, which is positive, and the electrons, which are negative. So what we have here first is called a first ionization energy. This is the energy needed to remove one electron. Then you would have the second ionization energy. This is energy to remove a second electron. And if I were to do third, fourth, I hope that you would start to pick up the trend. It can go all the way up to the eighth. Now, we got the first ionization energy, you remove one electron. You got the second ionization energy, that's the energy you need to get two. The third would be three, the fourth would be four. You then have what you can classify as having high or low ionization energies, but the bell is about to ring. So what we will do is we will finish this tomorrow.